Melting of the Arctic ice sheet. An ice sheet is a mass of glacier ice that covers surrounding terrain and is greater than 50,000 square kilometers (19,000 square miles). It is also known as continental glacier. The only current ice sheets are in Antarctica and Greenland. Ice sheets are bigger than ice shelves or alpine glaciers. Masses of ice covering less than 50,000 square kilometers are termed as ice caps. An ice cap will typically feed a series of glaciers around its periphery. Although the surface is cold, the base of an ice sheet is generally warmer due to geometrical heat. In places, melting occurs, and the meltwater lubricates the ice sheet so that it flows more rapidly. This process produces fast-flowing channels in the ice sheet. These are ice streams. This documentary is about the Arctic's melt and its consequences from an economic perspective. The albedo effect. The efficient north-south mixing of air may also play a part in the Arctic's amplified warming. The winds that rush northwards carry pollutants, including dust from European and Asian smokestacks, which has powerful warming effect over snow. In recent decades, there has also been a rise on levels of mercury, a byproduct of burning coal, in the tissues of beluga whales, walruses, and polar bears, all of which the Inuit eat. This is another reason why the Arctic is not virgin. But the main reason for Arctic amplification is the warming effect of replacing light-colored snow, ice, with darker-colored land or water, because dark surfaces absorb more heat than light ones. This causes local warming, which melts more snow and ice, revealing more dark land or water, and so on. Known as the albedo effect, this turns out to be a more powerful positive feedback than most researchers had expected. Most climate models predict that the Arctic Ocean could be ice-free in summer by the end of this century. An analysis published in 2009 in Geophysical Research Letters suggests it might happen as early as 2037. Some now think it will be sooner. It is hard to exaggerate how dramatic this is, perhaps not since the filling of America's vast forests in the 19th century, or possible since the razing of China's and Western Europe's great forests a thousand years before that. Has the world seen such a spectacular environmental change? The consequences for Arctic ecosystems will be swinging. As their ancient ice buffers vanish, Arctic coastlines are eroding. Parts of Alaska are receding at 14 meters a year. Niche habitats, such as meltwater pools on multi-year ice, are dwindling. Some highly specialized Arctic species will probably become extinct as their habitats shrink and southern interlopers rush in. Others will thrive. The early signs of this biological reshuffle are already evident. High Arctic species, including the polar bear, are struggling. Species new to the region, such as a mackerel and Arctic cod, are coming up in Arctic trawler nets. Yet, the shock waves of Arctic change will be felt much more widely. Melting of sea ice will not affect global sea levels, because floating ice displaces its own mass in seawater, but melting glaciers will, and the Arctic is shedding ice at a great range. Greenland's ice cap is losing an estimated 200 gigatons of ice a year, enough to supply a billion people with water. The Arctic's smaller ice caps and glaciers together are losing a similar amount. Before this became clear, the Intergovernmental Panel on Climate Change (IPCC) had predicted a sea level rise up to 59 centimeters during this century. Given what is happening up north, many now think this is too modest. A wilder fear is that a flood of Arctic meltwater could disrupt the mighty overturning circulation of the global oceans, the exchange of warm tropical and cold polar water. It has happened before, at least 7 times in the past 60,000 years, and needs watching. But recent evidence suggests that such a calamity is not imminent. Another concern, that the defrosting Arctic permafrost could release vast quantities of carbon dioxide and methane, appears larger. That, too, has happened before, around 55 million years ago, leading to a global temperature increase of 5 degrees Celsius in a few thousand years. Such risks are hard to pin down and possibly small. Many elements of the change in the Arctic, including the rates of snow melt and glacier retreat, are still within the range of historical variations. Yet, the fact that the change is man-made is unprecedented, which introduces huge uncertainty about how far and fast it will proceed. For those minded to ignore the risks, it is worth noting that even the more extreme predictions of the Arctic warming have been outpaced by what has happened in reality. In the long run, the unfrozen North could cause devastation, but paradoxically, in the meantime, no Arctic species will profit from it as much as the one causing it: humans. Disappearing ice may spell the end of the last Eskimo cultures, but hardly anyone lives in an igloo these days anyway, and the great melt is going to make a lot of people rich. As the frozen tundra retreats northwards, large areas of the Arctic will become suitable for agriculture. An increasingly early Arctic spring could increase plant growth by up to 25%. That would allow Greenlanders to grow more than the partly 100 tons of potatoes they manage now, and much more valuable materials will become increasingly accessible. The Arctic is already a big source of minerals, including zinc in Alaska, gold in Canada, iron in Sweden, and nickel in Russia, and there is plenty more to mine. The Arctic also has oil and gas, probably lots. Exploration licenses are now being issued across the region in the United States, Canada, Greenland, Norway, and Russia. On April 18, ExxonMobil finalized the terms of a deal with Russia's Rosneft to invest up to $500 billion in developing offshore reserves, included in Russia's Arctic Kara Sea. Oil companies do not like to talk about it, but this points to another positive feedback from the melt. Climate change caused by burning fossil fuels will allow more Arctic hydrocarbons to be extracted and burned. These new Arctic industries will not emerge overnight. There is still plenty of sea ice to make the North exceptionally tough and expensive to work in. 24-hour-a-day winter darkness and Arctic cyclones make it tougher still. Most of the current exploration is unlikely to lead to hydrocarbon production for a decade at least, but in the meantime it will happen. The price is huge, and oil companies and Arctic governments are determined to claim it. Shortly before the ExxonMobil Rosneft deal was announced, Vladimir Putin, Russia's president, announced plans to make it much more attractive for foreigners to invest in Russia. Offshore energy production. Offshore fields, especially in the Arctic, are without any exaggeration a strategic reserve for the 21st century, he said. For half the 20th century, the Arctic, as the shortest route between Russia and America, was the likeliest theater for a nuclear war, and some see potential for fresh conflict in its opening. Russia and Canada, the two biggest Arctic countries by area, have encouraged this fear. The Arctic stirs fierce nationalist sentiment in both, with a new regard to the northern areas. Some of the 8 Arctic countries are, in a modest way, remilitarizing them. Norway shifted its military command center to the Arctic town of Reitan in 2009. Russia is replacing and upgrading its 6 nuclear icebreakers, a piece of civilian infrastructure with implications for security too. Yet, this special report will suggest that warnings about Arctic conflict are, like the climate, overcooked. The Arctic is not terra nullius. Unlike Antarctica, which is governed by an international treaty, most of it is the market of half a dozen territorial disputes in the region. The biggest is probably between the United States and Canada, over the status of the Northwest Passage. Those two countries will not go to war, and the majority of Arctic countries are members of NATO. Yet, the melting Arctic will have geostrategic consequences beyond helping a bunch of resource-fatting countries to get fatter. An obvious one is the potentially disruptive effect of new trade routes, sailing along the coast of Siberia by the Northeast Passage, or Northern Sea Route, NSR, as Russian and mariners call it, cut the distance between Western Europe and East Asia by roughly a third. The passage is now open for 4 or 5 months a year, and it is getting more traffic. In 2010, only 4 ships used the NSR. Last year did 34, in both directions, including tankers, refrigerated vessels carrying fish, and even a cruise liner. Asia's big exporters, China, Japan, and South Korea, are already investing in ice-capable vessels, or planning to do so. For Russia, which has big plans to develop the sea lane with transshipment centers and other infrastructure, this is a double benefit. It will help it get Arctic resources to market faster, and also, as the NSR becomes increasingly viable, diversify its hydrocarbon-addicted economy. There are risks in this, of dispute if not war, which will require management. What is good for Russia may be bad for Egypt, which last year earned over 5 billion in revenues from the Suez Canal, an alternative east-west shipping route. So it is good that the regional club, the Arctic Council, is showing promise. Under Scandinavian direction for the past half-decade it has elicited an impressive amount of Arctic cooperation including on scientific research, mapping, and resource development. Yet, how to reconcile the environmental risks of melting the Arctic with the economic opportunities it will present? The shrinkage of the sea ice is no less a result of human hands than the plugging of the grasslands. It might even turn out as lucrative, but the costs will also be huge. Unique ecosystems and perhaps many species will be lost in a tide of environmental change. The cost is global pollution, and the risks it carries are likewise global. The Arctic, no longer distant or unbreakable, has emerged, almost overnight, as a powerful symbol of the age of man.